Welcome back to our podcast. Today, we're diving into the fascinating world of collaborative software and sync engines.
Thanks for having me. I'm excited to discuss Linear's sync engine and its implications for real-time collaboration.
Let's start with the basics. What exactly is a sync engine, and why is it crucial for collaborative software?
A sync engine enables real-time updates and edits across multiple users on the same file. It's essential for seamless collaboration.
So it sounds like these engines help us avoid those frustrating version conflicts we often face.
Exactly. They ensure that everyone sees the latest changes while managing any conflicts that arise.
Interesting. Now, I've heard about two methods commonly used in sync engines: operational transformation and conflict-free replicated data types. Can you explain the difference?
Sure, OT focuses on maintaining a consistent ordering of operations, while CRDTs allow for more decentralized conflict resolution.
Right, but I hear that OT can be quite complex. Why is that?
It's complex because it deals with various data models and operations, requiring intricate transformation logic.
That sounds challenging. So, what makes CRDTs more user-friendly?
They simplify things by supporting basic data structures out of the box, which reduces developer overhead.
But with CRDTs, there's a trade-off, right? I've read they can introduce metadata overhead.
Absolutely. They can become cumbersome in scenarios with permission controls or partial syncing.
So, what are the key requirements you look for in a sync engine?
I look for support of arbitrary data models, rich features like permission control, and a great developer experience.
And how does Linear's sync engine meet those requirements?
LSE abstracts the complexity away, providing an intuitive API that simplifies development.
Can you share a simple analogy or example of how easy it is to update an issue in LSE?
Sure, it's as straightforward as saying issue.title equals new title, issue.save. It feels like working with simple objects.
That's a big contrast from the complexity we discussed. Let's move to the technical aspects.
Great, LSE uses a model registry to define models and their metadata, making it structured.
That sounds organized. What about performance? How does Linear manage loading data?
They employ lazy loading techniques, ensuring that only necessary data is fetched when required.
So the system remains efficient. And how are client changes sent to the server?
Through transactions. Each interaction creates a transaction that gets processed in the background.
And do those transactions stay in sync with what's happening on the server?
Yes. The system receives Delta packets from the server and updates models in real time.
It seems like a lot of moving parts. How does Linear handle potential conflicts during synchronization?
LSE uses a simple last writer wins strategy to resolve conflicts, keeping it manageable.
That's genius. As we wrap up, what do you want our listeners to take away?
Understanding the importance of sync engines and collaborative tools, and how Linear's approach makes that simpler.
Thanks for sharing your insights today. It's been a pleasure discussing such an important component of collaborative software.
Thank you. I appreciate the opportunity to share.
And thank you to our listeners for tuning in. Catch you next time.